Aloha, Rich Halverson here. This is ITS128, and in this video I'm going to continue our Chapter 9, starting with function stubs. First of all, let me remind you of what I pointed out in the last video. Uh, are the If you go to the, let me get myself out of the way. When you go to the content page in Lamaku, where you have the course overview, which is the syllabus, and then down here you click on video archive. These videos right here, John Johnson's videos, cover his section on functions is his chapter 6. It's the same as our chapter 9, and he gives very good lectures there. His starting here with his chapter 6 is our chapter 9, and then also if you go back to Lamaku, the spreadsheet here, which I've opened up right here, has old videos on how to do the exact change and the leap year. I think that's leap year. Is that the the labs at the end of chapter 9 are exact change and leap year, and you also may remember exact change and leap year. We're back here in chapter 5 is exact change, and chapter 6 was leap year, and you were provided the solution there with the 2 asterisks. That's what that means, I think, in practice. Anyway, so you just need to take that code and make a function out of it here. So I will leave that to you. Let's go on. So let's go. Let's look at the challenge activities here in function stubs. This explains stubs. Let's see this one. Define stubs for the functions get user num and compute average. So it's this one and this one. And each stub should say fix me and then the function. Okay, so we want a def this one. And it's going to say print. Do I print it? Yeah, print fix me colon finish get user. I just go like this. Print that out. And return, well, followed by a new line, then also return -1. So return -1. Okay, so that's got user num, and compute average should be the same thing, except for it also has the function parameters. So I'm going to go like this. Copy. And then I'm going to go down here, def paste colon, and I can keep the same variable names, doesn't matter. Well, I'm just going to be lazy and copy this, paste it here. Wait a second. Control V. Okay. And I don't want it to be this. I want it to be compute average. I think I can just leave it. Yeah, it just looks like that. And then it returns -1. Let's see. Let's see if this is right. Ah, very good. Okay, great. Okay, let's see, are there any challenge activities here? Okay, this is just, more complicated functions. Of course, you can have branches inside. What are there any challenges? This is a challenge. This one? No. This one here. Okay. Let's see. Type the program's output. Grade 1. What's grade 1? It is calling this function normalize grade with a argument of 80. So what is, and then it prints out the result. So this, whatever this returns, normalized grade, it's going to either return upper bound, or it's going to return lower bound, or it's going to return grade, depending on. Okay, so first time it's 80, and it comes in here, upper bound at 72 is greater than upper bound. Yes, it is. So we print 72 because 80 is greater than 72. And then we're going to print 69, and 69 is between upper and lower bounds. So I think we just print 69. And 36 is below 54. You see if grade is less than the lower bound, then you just do the lower bound. So the lower bound is 54. Okay, is this right? Ah, yes it is. Very good. What's next? Cost is, this is the age, and this is the number of units. And so it's 22 is the age, so that means it's going to be 22. 22 is the age. If age is greater than or equal to 15 or less than, okay, so this is true. Since that's true, we're going to do this part here. And units is 18. If units is greater than 2, it is. So the cost is, and that's what we return. So we're doing this one. So it's units is 18 minus 2 is 16 times 500. 16 minus 500, is that 8? Wow, that's a pretty big number, isn't it? 16 minus 500. That would be like 8,000, I guess. Yes. Okay. Units is greater than 2. All right. Let's see if this is right. Wow. Yeah, that is right. Wow. Whew. Okay. Let's see. Well, anyway, you get the idea. So you should be able to here we're looping. We're looping 3 times. And each time we subtract 2 from result. So we subtract, well, anyway, you can, yeah, this is 1, so val of 2 is 1, so this is 1. So 1 times 2 is 2, and we subtract that each time this many times. So we subtract 2 3 times. So it ends up being minus 6. I don't know if that's right. Wow. Oh, I forgot the minus sign. Can I just fix it? I can't. All right, it's we're subtracting val 2 is 4, 4 plus 3 is 7. And we're going to do it twice. 4 plus 3 is 7. So we subtract 7 twice. That's minus 14. I have no idea if this is right. Ah, good. Well, anyway, okay, so you can do the last one. Ooh, okay, okay. Anyway, so you did the last one. What's this next one? Define print popcorn time. Bag ounces. The parameter is bag ounce. Okay, so you have ounces, and how long do you okay, so if bag ounces is less than 3, you print too small, or if it's greater than 10, you print too large. Otherwise, you just print 6 times the number of bag ounces, followed by the word seconds. So so here we have a function def print popcorn time. I'm going to just copy this, copy, paste, colon, if bag ounces is less than 3, then print too small. Elif, right? Elif bag ounces is greater than 10, then print too large. Else print 6. Oops, I'm doing some, this should not be like that. I guess I can do, well, I'm going to calculate it out. I'm going to introduce a new variable called SECS equals 6 times bag ounces, and then I'm going to print bag, yeah, I guess I can do it this way, SECS comma seconds. I wonder if this will work. I mean, I wonder if I get, if this passes. Should work. Oh, yeah. Okay. Yeah, does this thing do, see, it wants you to do it this way. See, this is the fancier way of doing it. But anyway, it doesn't matter. I got exactly the right answer doing it this way. All right, let's see, what do we have here? Define a function, find user tax. All right, so I'm going to define a function called this. Press start yet. This def this, and I'm just gonna call it age. And I'm supposed to if age is less than 40, then I guess I'm actually just returns the tax percent. So I can say return 0.33. age 60, I can do that. Return 0.29. Else return 0.13. It's an integer. Okay. Let's see. Oh. All right. Cool. Awesome. All right. So what's next? Let's see. You should be able to do this one. Reverse order. One line at a time. Okay, so it goes like 6, 5. 3 and 5. Okay, so this is 3 and 5. 5, 4, 3. This test here is because of this. That causes this 6, 5, 4, 3. All right. Is that what it's supposed to? All right. Okay, print values. Def print values. From to. What's that? For I in range 5 2 minus 1. I'm just guessing here. Print I end equals oops. From 2. This should be 2. It's actually 2 from, right? It's actually 2 from. So I'm going to say that it goes from 2 to from. No. All right, I'm just, okay, 2 from, but it actually is from 2. So I'm going to say it's from, and then, no. This is the from, and this is the 2. Okay, so it's 2 from. Okay, and it's going to go from, it's going to go from 2 plus 2 5 I'm just guessing here. Minus 1. All right, let's see what this does. I think it doesn't like my use of these words, so I'm just going to say T and F, and I'm going to say T and F. Let's see if this works. Nope. Really? It just doesn't like my returns? That's kind of nuts. All right, so let me take this out. Ah, good. Yeah, on one line it's separated and ending with the space, so I didn't have to put that. Okay, so great, got that done. All right, what's next? Functions are objects. I think this just explains that since a function is an object, you can pass objects to functions that you can pass functions to functions. There aren't any challenges in here. Are there any challenges in here? Okay, so it talks about common errors. I guess copy paste errors. It's so you should read this. Go through this. Beware. Copying one function to create another. So you're supposed to using that function create a new function called that and modify the function accordingly. So this function is defined, however this is not, and we're supposed to make it from this one. So I'm just going to copy this, copy, and I'm going to paste it here, but I'm going to name it this, copy, paste, and I'm going to say let's see, I'm just gonna change all the Celsius to Kelvin and the Kelvins to Celsius, and the minuses to plus. So I'm gonna change this to Kelvin, Kelvin, and I'm gonna change this to Celsius, Celsius, and I'm gonna this is Celsius. See, I don't run the risk of that. You should figure out an easier way to do this, a less error-prone way of doing this. Celsius, Kelvin, minus, and this be Celsius. Okay, so Kelvin comes in, and Kelvin, you take Kelvin, subtract that from it, and that's Celsius, and that's what you return. All right, how does this look? Very good. Okay, what's next? Okay, here's scope. Scope has to do with when you have a very you may want to reuse the name of a variable inside of a function, or you only need variables for the time that functions are executed, and so on. So there's this concept called scope, And there are local variables and global variables. Somewhere it says global variables. So like variables outside here are global, and these variables out here are visible inside here. See, this is uh, inches per foot. What's centimeters per inch? Is that on here? Oh, here. Okay, so here we have the centimeters per inch, and inside here we use it. See, and it's inside this this function here, and so and that's because this is global, and this is and because it's global, then it's visible inside. But for example, this is defined just inside this function. And so outside, if you try to use it outside, it's not, it has disappeared, because once this thing ends, uh, all of these variables that are used inside just disappear. So so anyway, here we define global variables, and the thing is, okay, so here, um, well, so here's an example where um, we have a global variable outside here, and we assign it some value, and then inside here we actually assign a different value to this variable, and it will not uh, this assignment does not change this one out here. So because when it sees this here on the left side of an assignment statement, then it creates its own new variable in a different space that happens to be the same name. So now internally, if you refer to this variable, it'll be the internal one. Now, if you don't want that, if you actually want them to be the same and you want to be able to change it inside, then you have to say this, global. Anyway, so let's see, are there any, I don't see any challenges. So next is, we are, okay, 9/11, okay. Here, this sort of talks about the same thing a little bit more. Creating variables, and here, this is a way to print all the variables. You can see that comes out like this. And there's functions to our objects, so they can be something that looks like that. This talks about how, when you are using the same name, how it's resolved. Of course, first it's local scope, then after that it's global scope, and after that it's built-in scope. Built-in scope are the functions like these kind of functions that are used everywhere. Okay, so anyway, so that's that. Are there any challenges? No challenges. Let me see. We're on 9/11. 10, 9/11. Okay. Function arguments. Okay. Okay, so in this section, we're talking about when you're passing variables or values or variables to the function itself. So here we are calling a function called birthday, and we're passing in a value, and here's the function, and then we inside here we try to do this, and whether or not this actually works and is able to change this out here, is able to change Timmy's age out here, has to do with whether the variable that's passed in is mutable or not. If it's immutable, in other words, if it's just a string or an integer, then it's not going to affect the outside. But if it's mutable, in other words, if it's like a list, or it's a container or something, then if you do mess with it inside, it does affect the outside one. So here, we define a list, and then we call this function here, and this function actually messes with the list here, and then so when it returns back out here, it's actually going to be affected by this. Okay, so because lists are mutable. All right. So we got some participation activity. Some challenges here. Let's see what this is. So we have numbers list and modify num are read from input. Modify nums has two parameters, list to modify and num, and decreases each element in list to modify by num. Okay, so we have this call modify nums with a copy of list numbers and modify num as arguments to avoid. So we have an input here, reads that in, and what's supposed to happen is you're supposed to then decreases by the second number, by this number. So you read in this list of numbers, and then you read in this number, and it's going to output. See, each element is 17 is subtracted from each one. See, 17 is subtracted from each one. So that's why it's minus 15, minus 10, and so on. So it prints out the modified list, and then it prints out the regular list. So okay, so we have to know how to call modify nums and pass it numbers list, and pass it a copy of numbers list and not numbers list itself. And to pass a copy, I buzzed by this pretty quickly. This is how you do it. You pass a copy of the list. It's the name of the list, followed by this begin square bracket colon end square bracket. So down here, I'm going to put modify nums parentheses numbers list dent comma modifier num. Okay, let's see. Wonder what I didn't do. Did I mean modify nums? Mod fee nums. Mod, yes I did. Yes I did. I did mean that. Modify. All right. How's that? All right. Very good. Okay. Looks like it worked. Let's look at the next one here. Write a function, add two elements. Def add two elements. okay, whatever, NL for numbers list, append NL, append default, is that right? Something like that. NL append default. I don't know. That's weird. Ah, well, what do you know? All right, so what's next? That's 9, 9, 12, 9, 13, and then 9, 16, 9, 13. Oh, default parameters. Okay, so so normally, you just have your list of parameters, and when you call the function, you have to have your arguments, and that's that. But there's a bunch of options for doing this. First of all, you can use keyword arguments. See, so because you might not have all of them or whatever, so you can do this. Say the title equals that, and the publisher equals that, and so that way you're skipping you're putting the author down over here because whatever, you're putting the version over here, and so that's another way you can do it using keyword arguments. You can use defaults. Defaults, okay. Position, okay. Where if it's not specified, see here it's 1, 2, 3, 4. If it's not specified, then it says default values. Default values. That's this. So if you have both positional and optional values, then you have to put the positional ones first. So and that's what this says. It makes sense. So here's an example of a bunch of defaults. All right, so no big deal. Are there any? Okay, here's a keyword arguments and default parameters. Okay, sure. Okay, I'm supposed to do this. A is the first one. Oh, A is specified as 5. Oops, 5. And then the next one is 2. No, B. B is 1. And then C is 2. He thinks. All right. Ah, yes. What's next? All right. Month, day, year. Month, day, year. Hour, minutes. Okay. So month is the second one, 12. Day is the third one, so that's 17. And year is the first one, so that's 2011. And then hour is 14, it appears. 14, colon, minutes is 46. And I guess we do this. All right. What's next? Okay, so this is A, this is B, and C is 5. This is A, this is B, and C is also 5 because the default here is okay. So you can do this one, right? Anyway, let's do this one here. Given that $1 equals 100 pennies, write a function number of pennies that takes two arguments, number of dollars and an optional number of pennies. Number of pennies should return the total number of pennies. The code reads three values from input and calls number of pennies twice. Okay, so all right, so the idea is that the second time it's called with just this argument as the number of dollars, there has to be the default there needs to be a default specified because here it's only called with one parameter. So so our function would look something like this. Let me def this, and it's going to be dollars and pennies, but we're going to default that to 0 pennies, and then we can just return dollars times 100 plus pennies. I think that'll work. He thinks. Let's see. All right. Well, that's nice. Okay. Oh, this is looks like a pretty complicated one. Okay, so we're gonna write a function called split check, and it's gonna we're gonna calculate the amount of tip and the tax and add it to the bill, and then we're gonna divide by the number of diners. And this is I'm gonna copy this dude right here, just like this. Ooh, I'm gonna copy the colon too. Copy, and I'm gonna put it right here. Paste. Okay, so oh, I have to say def, and it's gonna be calculate the amount of tip and tax. What are the defaults? 15% tip, 9% tax. So I'm going to call it tax percentage equals 0.09 and tip percentage equals 0.15 for 15%. And okay, and then I'm going to say, first I'm going to calculate the see, this comes in, 25 is the bill, and 2 is the number of people. So first I'm going to calculate the amount. Okay, so bill, tax equals bill times tax percentage. Okay, and tip equals, does the tip is calculated on the from the amount of bill before tax. Okay, so I gotta calculate the tip first. Tip equals bill times tip percentage, and then now the question is, the tip is counted before tax. So I guess the tax is okay. So the tip is, that's the tip, and the tax, I guess I gotta do bill plus tip times the tax percentage. And then what do I return? Oh. So I'm going to return, I'm going to sum all this up, I guess. Total equals bill plus tip plus tax, and then it's per person, right? So I gotta go return total divided by people. How's that? I'm gonna do this. Per person equals that, and then return per person. Okay, how's that? All right, let's see what this does. My output is that, and the expected output is that. My output is more, so I wonder if this should not be there. It doesn't make sense to me, but all right. Okay, so that's the answer. All right. Okay, so our arbitrary lists. Let me see. That's 914. Arbitrary argument lists, multiple function outputs, multiple function. Anyway, you can look at those. Watch the videos. Oh, engineering examples. What do we have here? Oh God. Trajectory function to compute gas volume. Ooh. All right, let's see what this is. Define a function to compute this. Copy. Def that. And so gas pressure, and what am I returning? Returns volume of gas. Use the gas equation V is volume in cubic. N is moles. This is moles. R is the gas constant. And T is the temperature. So pressure, temperature, and moles. All right. Well, I'm going to shorten this. Pressure, temperature, and moles. And I want to solve for V, right? Turn the volume. Pascals. Let's see. I gotta bring up the board. All right, let me see if I can put this down here. Oh, here's a whiteboard. How do I make it smaller? Okay, so we have this equation here. Oh. Okay, we have an equation. What happened to my equation? Okay. All right. Let's see. PV equals NRT. T. That's a T. So we want V equals something. So if we divide both sides by P, then we end up with V equals NRT divided by P. Okay, so that's what, so that's the equation. All right, so slide that over here. So V volume equals N. What's N? Again. Number of moles. That's the moles. Moles, M-O-L-E-S, times, what's R? R is the gas constant. R is the gas constant, this thing. Okay, gas, they say go. Gas constant, C-O-N-S-T. That's the R. The T is temperature, oh, that's here, times temperature. And the whole thing divided by, what's this, P? P is pressure. Okay, well, according to, okay, so according to algebra, I can just go like this, pressure. And so it's going to do it in order and everything. It's going to do this, then times this, then times this, and dividing the whole thing by pressure. And I want to return volume. All right, that's my guess. Let's see if it works. Ah, great. Okay, let's see. Is that it for this chapter? Okay, yes, that's it. So I have finished covering our chapter 9 on functions, and Hope this helps. Thanks for watching.